Okay, gentlemen, here we go. The counting principle. Now, the thing about the counting principle is what it lets us do is count all the different possibilities or combinations of things. For instance, if we had a die, right, one number cube, six-sided, obviously it's a cube, and it goes 1 to 6. That's easy to figure out how many possibilities there are, right? There are 6. 1, 2, 3, 4, 5, 6. But if I said, wait a minute, what is the probability of rolling 2 3s if I gave you 2 number cubes? Well, wait a minute. What are all the possibilities? How many possible numbers can I get when I roll 2 cubes? What combination? How many different combinations can I get? HOM.
12?
No, not 12. I've got 2 cubes, yes. But it's not 12. I could roll 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5. How many do you think, Miles? 36. It's not 6 times 2. It's 6 times 6. It's 6 squared. Okay? Now we're going to get to the counting principle. It says if one event can occur in m ways, right? If I roll 1 cube, here's the cube. All right? Let's say I roll 1 cube, right? And it's got 1, and I don't know how they're organized. 2, 1, 2, 3. However that, I don't know what a die looks like. Okay? Now I've got 2 of them. How many different ways can this one, how many different numbers can it fall on, Will R?
Like right there?
Yeah, this 1 cube, if I roll it, how many different numbers could I get? 6, right? Okay. And then if I roll this number cube, Nicholas, how many different numbers could I get? 6. Now, the question is, how many different combinations if I roll both of them? Well, see, the counting principle says if one event can occur in m ways, that's this one, and a second event can happen in n ways, that's this event, right? Then the number of ways that the 2 events can occur is m times n, or 6 times 6, right? So that would be 36. So now let me ask you this. What if I had a coin and a number cube, right? What are the odds of me flipping a heads and, hey, Miss Madison, yeah, come on in. What are the odds of, or not the odds, but the probability of me flipping heads and getting a 3? Well, remember, probability is what, Will K? What does probability mean?
Probability is like how many times something can happen.
Well, wait, what goes on top?
The
Yeah, and what does the numerator represent, Will R? Desired, right? Exactly. And what do I put on the bottom here, Alex?
the total probability of what you could get.
Okay, someone tell me what that denominator means, Kintara. The number of possible things, right? Okay, so if I'm flipping a coin and I'm rolling a die, right? And I want heads and I want a 3. Yeah? Okay, how many different possible combinations are there, Leo? There are 12. How'd you figure that out? 6 times 2, but where'd the 6 come from? Where'd the 2 come from? I'm sorry, wait, slow it down. For someone from the south, I need it slower. 6 possible things for the die and 2 for the coin, right? So 6 times 2 gives us, there are 12 possible combinations, right? How many of them gives us a heads and a 3? Nicholas? 2. Let's think about that. I can get heads 1, heads 2, heads 3, heads 4. Oh, scratch that out. Heads 5, heads 6, right? I could get tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6, right? So those are the 12 combinations. How many of them give me heads 3? 1. Nice. Okay? But you see, we didn't have to count all those possibilities, did we? We didn't have to write out each one of them to find out how many there were. We could use the counting principle to figure out how many there were, right? I'm sorry? Am I in the red? Okay, I'm going to have to go to the next song. But that's okay, right? Because we have infinite numbers of these things. Whoa, I'm way into the red. All right, guys, I'll see you at the next, I'll finish up in a second. Now, see, now I'm running.